So this is the chamber, and this is used in a sputter system. So there's 3 cathodes. We can send an RF, it's 50 ohms termination, or we can send DC as well. So it could be used for either. So this is the inside of the vacuum chamber. The turbo pump is connected to the bottom. There's a big hole on the bottom. That's where the turbo pump is. It's not straight down, it's at a 90-degree angle. Inside the sputter chamber, you got the cathodes, 3 cathodes. All this aluminum foil is to capture deposition, because the sample, your wafer, goes on this plate, and that's where the useful deposition takes place. However, the ejected atoms could be coming at a cone of angles. You're going to get a lot of overspray, and we use these aluminum foil to capture the overspray so that we don't have to scrub and clean every time. And on the cathode, we would mount our targets. So here is a silicon dioxide target. You can see the rings. This is where the magnet is focusing the plasma. So the electrons are going in spiraling patterns around this, and the ions are also in that spiraling pattern, and you can see the erosion of this silicon dioxide. And this is nearly spent. It's all the way down to the bottom. Here is an example of a zinc sulfide target that actually got spent, and actually it went through. You can see the holes. There, you can see through it. This cathode, the copper cathode insulator, and the anode, here is the same thing. There's an old one that we replaced, so you can see it clearly. This is the copper. And actually, I can see, this is from the zinc sulfide that I was talking about. I can see a little bit of copper missing here in that same pattern, because the plasma went through the zinc sulfide and started depositing the copper. All right, so pressure here is reading 30 microtorrs, so that's good enough. I'm gonna flow the argon. So pressure went up, so I'll raise the pressure here. I'm gonna run RF. I'll run the rotation. Pressure is at 4 millitorr, and then I drop back the pressure down to where I want. So there it is. You can see the plasma. Without the shield, you can see the plasma very clearly. There's the cathode. Aluminum is depositing, and my little microscope slide is down there. It's rotating down that table. All right, turn down the rotation. Turn down the gas so everything is off, and go to pumps. I'll turn down the turbo pump. There's copper. So we're going to do a lift off, or basically just wipe it off, leaving a void, and then we can measure the thickness of this copper film.
I'm going to position the sample under it, and the needle will drag across. So now you can see the screen. That's the sample.
There's the dot.
That's my Sharpie.
There's the stylus. You can see it move there, and then it's going to drop into the hole. There's no film, and that should give us the film thickness. So let's see. Okay, so there it is. Now there are some little debris or little dust particles on it. That's what has spikes on it. But we see a clear step. There's a tilt to it. That's because the whole sample is, those are tilted. The stage could be tilted, but we can level it. There you go. Now it's level, and you can see the step. The step we're talking about is right here. That's the film.
So we've got 49.6 nanometers, or
angstroms, right?
Or 496 angstroms.
500 angstroms. Actually, that was my target.